The concept of price elasticity of demand is essentially trying to answer the question of whether a change in demand is proportional, more than proportional, or less than proportional to a given change in price. More than proportional is elastic, and we see that with any calculation based on this formula that produces an answer greater than 1. Less than proportional is inelastic, and those are any answers based on the formula that produce an answer between 0 and 1. On the demand curve itself, we see that the elastic changes happen in the top half of the demand curve. Now this is true of any demand curve, and I'm going to say a little bit more about that in a moment. The inelastic changes all happen in the bottom half of the demand curve. There's only one point that's unit elastic, and that's the very middle of the demand curve, exactly halfway between the y-intercept and the origin, and between the a variable and the origin. So oftentimes we'll see something like this to make ourselves, to help ourselves see inelasticity or elasticity. But remember, we have to understand that this curve, what we're seeing is only the bottom portion of it. The rest of this demand curve goes on and on and on and on and on until it hits the y-axis, and therefore it's in the bottom half, so it's inelastic. Likewise here, this continues on until it hits the x-axis, so we're really only looking at the top half of that curve. One key that we can always look for is the effect on total revenue. In the top half of the demand curve, so if we see that we go from 5 up, so price is going to increase, maybe to 7, what we notice is that this box that we just gained, we'll call it A, is smaller than the box that we lost when we were at this point. So price went up and total revenue declined because A is smaller than C. Or if we went from 7 to 5, we would see that by dropping price, total revenue would increase because we would be gaining C at the expense of A, and C is bigger than A. In the inelastic portion of the demand curve, what we see is that when we drop price, again, we give up A to get C, so we're giving up a larger box, A, to get a smaller box, C. So we dropped price and total revenue went down. Likewise, if we went from 3 up to 5, the opposite would be true. Well, in both of those, what's really happening is this point, the unit elastic point, is where total revenue is maximized. So as we move away from that, obviously, if this is the maximum, then total revenue will decline. When we look at changes to the demand curve, well, really, we just need to think about what is the change doing to where the midpoint of the demand curve in relationship to the price that we're looking at. So, for example, here, P1 is occurring at the midpoint of D1. When I change the B variable, what that means is we're going to go from a B variable of 4 to 5. To prove that real quickly, we would go up 1 and over 4, or up 1 and over 5 to get to D2. So when I do that, what occurs is this point, this price P1 on D1 used to be the middle point, but because effectively I have shrunk the demand curve to get it down to be D2, now that is occurring in the upper half. So I've made this demand curve D2 relatively more elastic. That word relatively is really important. If you say more elastic or less elastic, remember all demand curves are 50-50, so they can't be one or the other. So you have to say relatively to compare it to another demand curve. Here, when I changed the A variable, well again, I took P1, and at P1 it was at the midpoint, and when I shift the demand curve by changing the A variable from 400 to 600, well, that same price P1 now occurs in the lower half. So by shifting this out, I've made it relatively more inelastic or relatively less elastic. Finally, you do see these down here sometimes. They're not very realistic. They're just kind of extremes that we can use to make a comparison to. This is what we call perfect elasticity. The idea is that P1, infinite amounts are demanded. So we don't actually have any amounts here because you could sell as many as you want, or as many as you can think of can be demanded at P1. Now obviously, if people demanded at P1, then at P3, a lower price, they demand just as much. The problem is when we raise price to P2, I go looking for a quantity to find, and I keep going to infinity and I don't find anything. So if I raise price just a little bit, we have zero demand. So a tiny change in price results in an infinite change of demand, or a demand goes back to zero. Math teachers might be mad at me for using infinite wrong. This is what we call perfectly inelastic, so it's vertical. This was perfectly horizontal, by the way. So perfectly inelastic, well, is just the opposite. No matter what I do to price, the demand remains the same. I can lower it, I get the same amount. I can raise it, I get the same amount. Well, again, both of these are unrealistic because, of course, there's not infinite demand for anything because there's not infinite people or anything like that. Likewise here, you can't raise the price forever because there's no one with an infinite amount of money, so of course, at some point, you would have no demand left.